Name is Ege Esin.
Hello, it's Arshan.
Today we are going to present you our EE313 final project, Photophones.
Let me talk about its history briefly. Photophone was invented in Bell's laboratory in late 19th century. Alexander Graham Bell called it as his greatest invention he has ever made. And today it plays an important role for high-speed data communication in the form of fiber optical wires all around the world, and it's very popular. And I am leaving the stage to Ege.
In our project, there will be two main parts. The first one will be transmitter part that I'm talking about, and the other part, receiver part. So let's start with the transmitter part. The transmitter part starts with microphone driver. We drive the microphone in order to convert the sound vibrations into an electrical audio signals with using capacitor and resistor, as you can see in the LT Spice. However, our output voltage was too low to operate the system when we drive the microphone. So we put our voltage to preamplifier, and this amplifier increased our voltage. Also, you can see this preamplifier in LT Spice. Then we added operational gain controller to obtain a relatively constant amplitude audio signal. With this circuit, we prevent changes of output's amplitude, as well as the distance of the sound source to the microphone. After this part, we summed our signal with the reference signal, which is 2 kHz and 1 peak-to-peak voltage amplitude by using a summing amplifier. The reason we use reference signal is at the receiver, the amplitude of the signal will be treated as the measure of signal strength, since it's constant. Any decrease or increased detector in the receiver will be the indicator of the degree of coupling of transmitter light into the receiver. And our final circuit in the transmitter part is laser driver circuit. Since laser should be driven with the current, we use transconductance circuits in order to turn the voltage to light. So when we give voltage to this circuit, we obtain the light. And right now we can go to receiver part.
Let me explain receiver module of our design of our photophone. After modulated light transmitted by laser, this photodiode picks it and converts it into current form signal. And this current induces voltage over this R5 resistor. And we decide the value of this R5 resistor by experimentally, but it should be as large as possible in order to obtain sufficient voltage on it. And then we take this voltage to this amplifier circuit, and the gain of this amplifier circuit 6.5. You can see voltage division over this node. And then we put this output voltage into the low pass filter. Since our modulated light consists of two components, one of them is lower frequency audio voice, and the other one is reference signal, which is 20 kilohertz in our design. And I said low pass filter, but this actually behaves like an passband filter because in order to eliminate the ambient light, we made the low frequency cutoff 200 hertz, and the higher frequency cutoff around 3.5 kilohertz, and this is optimal for human voice transmission. And this is consists of high pass and low pass filters. Both of them are second order, and then overall filter is fourth order. We put the output of this low pass filter into the power amplifier circuit, which drives the speaker. Our speaker is 8 ohm, 1 milliwatt. It has 1 milliwatt power rate. And first stage of our power amplifier circuit is common source with source degeneration, NPN, this huge transistor. And then we use two common collectors by connecting them from their emitters in order to for impedance matching for maximum power transfer. Because when we look from emitter sides, the output resistance of this configuration is very low, and because of that, we use common collector. And then, in order to obtain the high frequency component of our signal, we pass it through this high pass filter, which is also second order, and then we put this into peak detector, and this peak detector behaves like an half-wave rectifier and takes the peak value as DC, and we put this DC into this comparator circuit. This comparator circuit compares this DC with DC biases, and then decides which node to excite. B, G, R, and B. These letters correspond to the colors of our RGB LED: blue, green, red, and blue. And depending on the which node is excited, our RGB gives light. And then we can, by looking at these colors, we can decide strength of our reference signal. This is end of our presentation. Is there anything you can add again? And ciao.
Thank you for listening.